When we had just one single process control block, it was a large contiguous data structure. We had to maintain separate copies for every single thread, even though they may share some information. Whenever we need to context switch, we need to save and restore this entire data structure, and it is large, we said. And finally, it's just this one data structure that's used for so many different operations, for scheduling, for memory management, for synchronization. If we want to customize any aspect of that, we are potentially going to affect multiple OS services, and so it makes updates a little bit challenges. So all in all, there are multiple limitations to this approach of using a single process control block structure to represent all aspects of the execution state of a process. Scalability is limited due to the size. Overheads are limited because the need to have private copies. Performance is affected because everything has to be saved and restored. And then flexibility is affected by the fact that updates are a little bit more difficult. In contrast, when we have multiple data structures, we actually end up with multiple small data structures. The information that was contained in the original process control block is now maintained via pointers by pointing to much smaller data elements. Then it becomes easy to share portions of that information. We will point to the same data structure for those components of the state which are identical across threads or processes, and we will create new elements when we need to have different information. On a context switch, only that portion of the state that actually needs to change will be saved and restored. And then both any kinds of modifications will impact only a subset of the data elements, and then the interactions between the user-level library and the system will also be carried out through a much smaller, more confined interfaces. All in all, this trend to use multiple data structure leads to improvements across the board. We gain on scalability, on overheads, because we don't have to have separate copies for everyone. We have improvements in performance because context switch time can be reduced, and we have more flexibility. As a result, operating systems today typically adopt this type of approach for organizing information about their execution contexts.